You know, have you ever tried to give an AI agent a really big, complex project? If you have, you've probably seen this happen. It starts out great, full of promise, and then, somewhere along the way, it just gets stuck. Well, let's dive into why that happens. Because it turns out there's a really fundamental reason single AI agents tend to fail at long, complicated tasks.
So what's the deal? Why does an AI that's so smart with small stuff just completely fall apart when you ask it to do something bigger? It's a great question, and it's not just one single thing. It's actually a few predictable ways these systems tend to break down.
The heart of the issue is something we can call the super agent problem. We kind of have this idea, maybe from the movies, of one single, all-powerful AI that can come up with a strategy, manage all the steps, and execute every tiny detail perfectly. But, in the real world, asking one agent to be the CEO, the project manager, and the specialist all at once, that's just a recipe for disaster.
And this slide right here, it breaks down exactly why that failure is so predictable. First up, you've got context dilution. Basically, the original goal gets all fuzzy after a bunch of steps. Then there's tool saturation. You give an agent 100 different tools and it just gets confused about which one to pick. And finally, there's this really fascinating problem called lost in the middle, where these big language models literally start to ignore instructions if they're buried too deep in a long prompt.
This quote just nails the context dilution problem, doesn't it? As the agent is working, that crucial first instruction, the whole point of the task, it just starts to fade into the background noise. So if a single super agent is a no-go, then what's the answer?
Well, the solution actually comes from a classic idea in software engineering: separation of concerns. The idea is, instead of having one agent do everything, you create a new chain of command. You build a team.
And this is where we get to the main event: hierarchical AI agents. We're talking about a system where you have a whole team of specialized agents, all collaborating like a well-oiled machine. Each one has a very specific job, and they pass information up and down the chain to get the big goal accomplished.
The best way to think about this is like a company's org chart. It's a perfect analogy. At the very top, you have your executive agent. Its only job is big picture strategy, breaking the main goal into smaller projects. Then you've got the project managers. They take those projects and coordinate their teams of specialists. And at the bottom, you have the specialists themselves, the doers. Each one is an expert at one very narrow thing.
And what's so cool about this is that the structure itself is designed to crush those problems we talked about. It fights context dilution because each agent only gets a small, focused contextual packet, no more noise. It fixes tool saturation because each specialist only has the one or two tools it actually needs. And this also gives you model flexibility. You can use a huge, powerful model for the executive planner and then way cheaper, faster models for the simple specialists down below.
Now, this isn't just some theory on a whiteboard. Let's take a look at how this all works in the real world with a company called Treecapital AI. They've built a framework called Anven that's designed specifically to build these kinds of powerful, enterprise-level agent systems.
So Treecapital AI's whole mission is to solve what they call the trust gap in enterprise AI. And they do that by building what are known as sovereign AI systems, using private large language models like their Anven model. The key here is that it can run entirely inside a company's own secure system, which means their sensitive data never, ever leaks out.
This table is awesome because it maps their tech directly to those challenges we've been discussing. To handle context dilution, they use a RAG native ecosystem. RAG just stands for Retrieval Augmented Generation, which is a fancy way of saying the AI always bases its answers on a private, factual knowledge base. To beat tool saturation, they use something called precision fine-tuning with methods like QLoRa, which lets them create these super specialized agents really efficiently. And then, to manage the whole thing, they use powerful orchestration tools like LangChain to keep the entire workflow running smoothly.
And check this out. The results are seriously compelling. By using these specialized, fine-tuned models, they can get really high performance on smaller, more efficient hardware. We're talking about a potential reduction in operational costs by up to 60%. That is a massive, massive gain in efficiency.
But of course, no solution is a silver bullet, right? While these hierarchical systems solve a ton of old problems, they also introduce a whole new set of challenges, new kinds of bottlenecks that you have to manage really, really carefully.
The first, and honestly the biggest challenge, is task decomposition. This basically means the success of the entire system, everything, hinges on that top-level executive agent. It has to be able to break down the main goal into a plan that actually makes sense. If that initial plan is flawed, well, everything that comes after it is built on a shaky foundation.
This slide shows that trade-off perfectly. On one hand, the benefit is you get incredible task specialization. Your low-level agents are true experts. But the challenge? If that expert gets a bad plan from the boss, it's just going to execute that bad plan flawlessly. It is the ultimate example of garbage in, garbage out.
And this quote just sums it all up. This new way of building AI solves that lost in the middle problem, but now you run the risk of getting lost in the org chart. The real trick is designing the handoffs and the communication between agents just as carefully as you would if you were managing a team of actual people.
So why does any of this really matter? What's the big takeaway? It's that we're watching a fundamental shift in how we build AI systems. The future of AI isn't about creating one single, perfect, all-knowing brain. It looks like it's going to be about building a really great team.
This really says it all. We're moving away from this idea of a single monolithic AI mind and toward building modular, scalable, and collaborative AI teams. Each member is an expert, and working together, they can take on a level of complexity that no single agent ever could.
And that kind of leaves us with one final big question to think about. As these systems get more and more woven into our world, maybe the real path to smarter and more capable AI isn't about building a single godlike supermind. Maybe it's about getting really, really good at building and managing an amazing team of smart, specialized agents. What do you think?